Hi there, infinite greetings. Mr. Sutton here, bringing you the Pre-Cal Honors 9-2 Extra Practice Number 1 solutions on intuitive infinite limits. For this problem, we need to use this graph to first find the limit as x approaches a. So we have to look at this as left versus right. As we come from the left side here, we're approaching -3 for the y value as we get close to the x value a. And then as we approach from the right side, it looks like we're going to infinity. So because the left and the right-sided limits at a don't match up, the overall two-sided limit at a does not exist. Now for the next part here, as x approaches -infinity, that's saying as we move to the far left for our x values, what y value do we have? And that looks to be -3 here, so that's going to be the limit at -infinity. On this graph, for part A, the limit as x approaches a, let's see, looking at this from the left and the right, as we come from the left side, that looks to be like a left side limit of 4. As we come from the right side toward a, it looks like we're approaching y equals -3. Since the left and the right side limits at a don't match up, the overall limit at a does not exist. Next, limit as x approaches infinity, that's saying as we move to the far right, what y values are we approaching? Well, as we move to the far right, it looks like we're going down forever. So that would be -infinity or simply does not exist. Either way would be acceptable. And now, as we approach infinity to the left side, moving to the far left, we're oscillating back and forth, but we're getting closer and closer to a number. And it's kind of hard to tell what number that should be, but it looks to be like maybe -1.5-ish. So we're going to go with that. On this one, the limit as x approaches a for this graph, as we approach a from both the left side and from the right side, we're heading toward the same y value, which looks to be roughly 2. And then limit as x approaches infinity, we're saying as we move to the far right, what are we approaching? Well, moving to the far right here, it looks like our graph is going down forever. So for y values, we don't have a limit. You could say does not exist, or you could be more specific and say we're approaching -infinity, dne with direction. For this one, we're trying to find first the limit as x approaches a on this graph. So as we approach a from the left and the right, it looks like we're heading toward a value of 0 for the y value, so we're going to go with 0. This next one, as x approaches infinity, as we move to the far right, it looks like we're going back and forth and we're getting further and further apart. So if that pattern continues, because we're oscillating back and forth and not approaching a single number like we were over here at x equals a, we would say that that limit does not exist. For this problem, we're analyzing this graph in a few places. First off, these first three deal with what we're doing at 3 for limits. So as we approach 3 in part A from the left side, it looks like we're going down forever. So that's a limit of -infinity or dne. From the right side, as we approach 3 from the right, we're going up forever to +infinity. And then as we approach 3 from both sides, well, we're going to different infinities. Even if you're going to the same infinity, you could say dne for this. But since the limits don't even have the same infinity, you really have no choice but to go with does not exist for this one. You can't even specify a single infinity for that. All right, so moving on now to option D, or part D rather. As we approach -infinity, as we move to the far left, we have this asymptote, horizontal asymptote at y equals 3. So y equals 3 then. 3 is going to be our left-sided limit. And as we move to the far right with +infinity, we're approaching the same horizontal asymptote. So again, we have a limit of 3. On this problem, we're going to analyze the limits at x equals -1 on this graph, and then we'll take a look at the infinite cases here. So for part A, as we approach -1 from the left side, so here's -1, we have a vertical asymptote there. So you know right away that all of these limits are either going to be some kind of infinity or just overall dne. So as we approach from the left side toward that asymptote, we're going down to -infinity, which you could also call dne, but -infinity is more specific. Same kind of idea as we come from the right side, we're going to +infinity, which is just another kind of dne with direction. As we approach -1 from both sides, well, now you have to choose between negative and +infinity. You can't write either infinity. That's just pure DNE, does not exist. There's no way around that if the limits don't match up. You can't even call it a single infinity. All right, for part D, as we approach negative infinity, we're heading towards this horizontal asymptote on the x-axis. So that's a value of 0. And for part E, approaching positive infinity, going to that same horizontal asymptote, we're still getting 0 as the limit. For this problem, as we approach x equals 0 from the left side for part A, so that's right here, we're heading toward the y value negative 3. As we approach 0 from the right side, still heading to negative 3. And since these two limits are the same from the left and the right, the two-sided limit at 0 is also going to be negative 3. For part D, as we go to negative infinity, it's kind of hard to tell, but it kind of looks like we're getting closer and closer and oscillating toward this y equals negative 4 line here. So it kind of looks like there's a horizontal asymptote at y equals negative 4. And that's going to be true as you move to the left, so that would be the left side limit. And it looks like that also holds true as you move to the right. So positive, negative infinity, those limits should both be negative 4 based on what the graph looks like it's doing. For this problem, we're taking a look at the limit as x approaches negative 2 for this graph. So part A is dealing with the left side limit. As we approach negative 2 from the left side, we're going to negative infinity. As we approach from the right side in part B, over here, we're going to positive infinity. And either of these could have been written as DNE. This is just more specific. But now, as we approach negative 2 from both sides, since the left and the right limits don't even have the same infinity, there's no choice here but to write does not exist, or DNE, for that limit. Now down here, limit as x approaches negative infinity. As we move to the far left, what is our graph doing? Well, it looks like it's going down forever, not like very steep down, but still going down in terms of y values. So that's going to be negative infinity for that limit. As we move to the far right with positive infinity now, in part E, looks like we're going up forever, so that would be positive infinity. And both of these could also be written as DNE, but this is a little bit more descriptive. On this problem, we're taking a look at the limit as x approaches negative 1 from the left, the right, and from both sides. From the left, looking at this, we have a vertical asymptote at x equals negative 1. Approaching that from the left, we're going down forever, so that's going to be negative infinity. From the right, it looks like we are going up forever, so positive infinity for the right-sided limit at negative 1. Since these infinities don't match up, you could say does not exist without specifying any kind of infinity for x approaching negative 1 with no direction specified. And you also could have said either of these was infinity. These are just a little more descriptive in terms of what direction we're veering off into. Now for D and E, we're going to the far left and the far right and asking what y value we approach as we do that. As we move to the far left, we have this horizontal asymptote at x equals negative 2, or y equals negative 2 rather, that we are approaching. So negative 2 is our left side limit, or left infinity limit rather. As we move to positive infinity, as we move to the far right, we are also approaching y equals negative 2. So that's going to be the same limit because we're approaching the same horizontal asymptote. On this problem, we're trying to figure out as we approach the far left and the far right what this graph is doing. As x approaches negative infinity, as we keep moving left, it looks like our graph is just going to go down forever. So that would be negative infinity. And as we approach the far right, positive infinity, we're going down forever in that direction as well. So also negative infinity. And for either of these, you could have said does not exist. This is just a more specific version of DNE. On this problem, as we approach negative infinity, that means we're going left forever on this graph. We're heading towards negative infinity for y values as well. So that would be our limit, which you could also write as DNE, but this is a little more descriptive. For the next one, as x approaches positive infinity, we're approaching this horizontal asymptote that we seem to have at y equals 2. So that's going to be a limit of 2 there.